Oh, hi, my name's Andy, and I'm busy and important and couldn't come. So that sucks for you.
It's the Hacking Show with Kirk and Felix. Welcome along to Hackhead. This is a very special show for us because after this we can relax.
Last show of the day.
For us, two more shows to go, almost the end of TechEd. So my name's Kirk Jackson, I work at Xero in the security team, and today I'm joined by my colleague, not Andy, his name is Felix.
Good day everyone, my name is Felix and this is my first TechEd. I'm in Microsoft Ignite. I work with Kirk at Xero and he's now a manager. Hooray for pushing pencils and what's not.
I'm really bad at being a manager. So today we're going to talk about building an antisocial network and what that really means, some of the threats that come with building a social network.
Now really guys, a hands up please if you have a social network of some sort, say Twitter, LinkedIn, Facebook, hands up. Alright, there we go. These days everyone's connected. I mean, there's a social network for anything. Like if you want to talk to people, use Facebook. Professional relationships, LinkedIn. And there's quite a few obscure ones we'll not go into today. What's so difficult about building it? I mean, it is a well-established market. Unless you have the technical know-how and a lot of money to throw around, it's difficult to attract users. And once users begin to come into your social network, you have to scale it, both the infrastructure-wise and actually to ensure that the user will grow at a constant rate. And once the users are already signed up for it, you have to protect them. I mean, you do have a moral and ethical obligation to ensure that their data doesn't get leaked or get accessed by unauthorized third parties, hackers, or dodgy people alike. Once you've defended your users, you have to defend yourself, your brand. What's stopping you from, what's stopping from a hacker group from sending an email from your behalf? Let's say if you started a social network called Bookface, for example, let's not be controversial here, and sending an email from, say, admin from Bookface saying, hey, please reset your password. Kirk, your screen.
I know, just a sec, I'm just doing something.
Okay, everything's under control. Yep, from scamming your users, and that is actually quite difficult to... Oh dear, Kirk, what are you doing?
Damn it!
We tried. Yep. And at the same time, we need to handle the user's content safely. For example, you have an account, your neighbor has an account, you uploaded quite a few private photos on it, and you don't really want your neighbors to see them. So how would you set your privacy policy, and what's not? Continue. There's been numerous attacks on existing social networks in the past. So this is just did a quick intent search on it, and this is what we found. October 2005, anyone's familiar with the XSS worm? Sammy's my hero? Nope.
It was on this thing called MySpace, which, I don't know, a lot of people were using back then.
Back in the days before Live, is it like LiveJournal, MySpace, Bebo? Any of those things still alive these days? I don't know. So someone managed to exploit a vulnerability in the web application and managed to create a piece of code that self-replicates to everyone else's walls once someone visited the existing piece of code. And eventually it spiraled out of control and MySpace team has to take the website down for an emergency maintenance. And a lot of other social networks has faced threats of denial of service attacks. I mean, if you're building a social network, chances are you're made out of money and people want to get that money off you. And once you have a lot of users on your network, the attackers may not just want to attack you as a company, they might want to attack your users. I mean, customer data is a goldmine for spammers, phishers, and what's not. So there's all sorts of scams and phishing emails that's been going around. Well, scams and phishing's been going around before the internet, hasn't it, Kirk?
Yeah, I think Nigerian princes used to visit people by horse and cart and try and steal their gold.
Exactly, but at least that's regionalized somewhere in Nigeria, or, you know, they can move to Kenya if they're lucky. But hell, they can't reach New Zealand, or there'll be a long delay.
So, but I'm not scared, and I've had a pretty successful history of product launches at this Dragon's Den called TechEd. Last year, I almost launched a fairly successful Lego rental business. I had one interested investor contact me after the talk and say he would like to play with my Lego, but unfortunately he didn't have $20,000. Prior to that, I've also launched a daily deals website at TechEd, which is called 0 Days. It didn't go that well. What else have we done? We've launched mobile apps. Well, today we're going to launch something new. We're not scared of the world, and it's time that we made money. So today I would like to introduce to you the antisocial network. Now, the antisocial network is all the good things about social networks and none of the bad things.
So that means no pokes, no likes, no wars, no friends list, no ads. Have a look.
So you've already got an email account. You use it for everything. You don't need to remember passwords because you've already got a password for your email account. You don't want to see any advertising. That's boring. And no way are you going to do all these newfangled things. You know, email's been around for 40 years. Let's make a social network that's built on email. Now, antisocial network, it's going to be exciting. People of all ages and creeds will use it. Mostly people over 50, probably, because the younger people actually like social networks. But you don't need to sign up. You don't need to create an account. You don't need to have friends. You have friends in the real world. You don't need them online. You already know the email addresses of your friends. Why would you need to, I don't know, friend them on Linkster or MyFace or something like that?
Let's not be controversial.
So all you need to do for this social network to use it is to send an email. So our first user of the social network, his name is Oliver Rigoli. I discovered Oliver, he's our beta user, by typing in random name into Google. And there he was, Oliver Rigoli, ready to use our service. So he starts off the service. He wants to share some content with his friends. So he sends an email to post@antisocialnetwork.com, and he says, like, hey guys, I'm 60 and I have a picture of my cat to send you. And he doesn't quite know how to do the attachments, so can you help me attach stuff? Oh, by the way, I have a virus. And that's all he needs to do. And the antisocial network's sitting out there waiting for Oliver. Hey Felix, while I'm talking, would you be able to turn off the thing that speaks every time I do something? Oh yeah, just turn off the volume. Good idea. So it sends off. It's good to have someone technical on the team. Sends off an email. The antisocial network says, "Hey, we've made a post for you. Here's the link. Go to the antisocial network. It's sitting there for you. You can add recipients by entering the email address, or you can just reply to this and CC people. So I might invite my son Kirk. I do have an Italian heritage, so it's possible. Felix, I don't know your email address, and say, hey, really, I've got a virus. And those messages will show up on the post on the social network. I can invite other people and send them emails.
Yeah, invite me.
And life is good. If I'm slightly more sophisticated and I don't want to do replies via email and create posts, I'm now logged in. Didn't have to enter a password. Wasn't that amazing? Have you ever tried to explain to someone why they need a different password for the email than they do for Facebook? I mean, email is your master password, right? Why do you need other passwords? So a new picture of my cat. And, you can do stuff like make stuff underline and bold and put emotions in it using emoticons or whatever. Cool, so this is the antisocial network. It's going to take off in a big way. You're all invited to the beta launch. As usual, I'm looking for investors. I've come up with the idea, so obviously 97% of the company is based on the idea, and the 3% is based on your $1 million. How is this built? Well, it's a contemporary ASP.NET MVC app. Uses MVC5, Razor, .NET 4.5, SQL 2012. Couldn't bother downloading the new one. Entity framework. And it sits in Visual Studio in a regular-looking solution, all nice big Arial fonts. There's 2 points of access. There's a computer sitting on the internet that accesses the website, views, view models, controllers, style. And then there's email ingress, and so I'm using a product called Mailgun just to make that simple, because parsing email and downloading it off IMAP and stuff is just a pain in the ass. And so what Mailgun lets you do, this is not a sales pitch, is you can add your domains in there. It will receive the email for you, and it will turn the incoming email into a post to a URL that you specify, and there'll be a bunch of parameters like, from address to address, attachment 1, attachment 2, HTML, plain text. So it's really easy to program against, just an MVC action you need to write. So that's a social network. Everyone excited? Cool. Oh, there's a schema. Every network needs a schema. It's based on the same schema as every other social network. So you have users do things and they reply to them. Other people receive the things that people do. Content is stored, and the way people log in is via access tokens. They get sent via email.
All right.
So Felix is the persona of the attacker, and he's running a nasty Linux desktop.
Indeed. Thank you very much, Kirk. I'm going to play the bad guy here. I always play the bad guy. Why can't you play the bad guy for once? So let's say, imagine this is the attacker's laptop. He's looking at the website, and he thinks, great, how do I attack a website? Actually, how many web devs do we have here? Can I have a look?
Web developers?
Web developers?
Represent.
That's quite a bit. Cool. So let's talk about website security. So normally when an attacker looks at a website, they try to scope out their work. They try to find the weakest link in the website. They see where they can actually put in custom inputs, fiddle around with certain things. And here we found, I can post something to the website. Let's talk about cross-site scripting. What happened?
Oh, it just auto-completed with some very lonely-looking subjects.
Oh, that's okay. So a lot of websites on the internet are vulnerable to this thing called cross-site scripting. Has anyone heard of it before? Yep, great. So what exactly is it? Chances are if you worked in web application development space, your security team has probably made an alert box pop up once every while on your web application. And it's a bit of a mild nuisance, nobody like alert boxes. This is the 21st century after all.
I mean, like the first 5 times or something, the alert box annoys you, and then Chrome and Firefox and Internet Explorer stop showing them. So
it does. At least use a model dialog or something that's prettier.
Lightbox or something.
Sure. So most websites are vulnerable to cross-site scripting, and that occurs when you're actually not encoding your output correctly. So let's try to put in some JavaScript tags or just HTML tags in the subject. Say script alert. You guys all have all seen this before, and I have something new. Wahahaha. I'm evil. Oh no.
Haha, I'm too clever for you.
Take 2. So as you can see, the script tag got displayed on the page as it is, as opposed to getting executed or being treated as a part of the DOM element. This means that the output has been HTML encoded. So this would actually get executed as a JavaScript element. Let's try again. Let's add a reply here. Script alert 1.
No way.
No way, you think? Well, that too.
The funny thing about this was he actually found security flaws in my app while we were preparing this talk.
Well, that's the best part. It's fun, isn't it? I'm currently using an intercepting proxy to actually intercept all the traffic that's going between my browser and the anti-social network. So as you can see, when I posted this when I posted this message. Can you see it in the back?
Yep. Oh, I'm not at the back. Sorry.
At the
I can
front.
see it at the front, this far from the screen.
So, in fact, this is what's being sent. As you can see here in the input, it is being encoded on input, on the client side. So what would happen if we tried this? We'll turn intercept on. Take 3. We click save, and you notice it opened up a prompt for you to fiddle with certain parameters.
So you can do this with tools like Fiddler, tamper data in your browser. What's that proxy? We're using one called Burp, which is
free,
about
but
$300, but it's worth it.
yeah, those are the free version. So let's try to put in an image tag, a broken image tag, and if you float your mouse over it, it does something. Alert 1. Let's go with that. Forward. Do I see my broken image?
That didn't work.
Didn't it?
Dope.
Well, most of you probably have already seen this before. Sure, it is an alert box, but how much damage can you actually do with an alert box? Well, the alert box is merely a proof of concept that you can actually execute client-side JavaScript. Once you have JavaScript running, you can do more or less anything the user can do with some restrictions. So in here, an attacker, once they get cross-site scripting running, they can, say, deface a website by modifying the page elements. Or they can actually steal a user's session information. So for now, let's try an actual real attack. Kirk, would you mind bringing up your screen for a moment? Yep. What's your user's account? Sorry.
Oliver Rigoli at gmail.com.
Oliver Rigoli at gmail.com. Okay. Give me 1 moment to prepare this, if that's okay.
Okay, so what Felix is doing now is copying and pasting from one document into another document.
Hey, I got this pre-prepared. Thank you very much.
We said I'd talk while you're doing it. Just press the up arrow 3 times, the down arrow twice.
Goodness
This
gracious.
is called filling in the awkward gaps during our presentation.
You're doing a very fine job, Kirk. You are doing a very fine job.
Why is it on my screen?
Why is it on your screen? Yeah, let's put it back on my screen. Can you see in the back?
So the interesting thing about this website is that when someone gets an email like I did and click on the link, it logs them straight into the website using the email. So the attackers looked at the URL that they get when they use the website and gone, oh, there's an access token in there. If I could steal someone else's access token, then I would be able to log in as them.
Exactly. So if you manage to steal someone's access token in the URL, you'll be able to reuse the access token later in order to impersonate another user.
And this is very similar to like password reset links in common websites that gets emailed out.
So what we have here is a pre-encoded input. Just trust me, this is actually this. It just looks uglier.
Well, that's what you're doing.
That's what I'm doing.
Okay.
Yeah, exactly. I can actually just paste it in raw, can I now? So I will now try this again.
You're making me dizzy.
Am I? Sorry. My apologies. I will now attempt to post the dangerous payload in here. Let's see how it goes. Save. We'll change the reply to HTML with the dangerous payload. Forward. And now that is in the system. As you can see, nothing is showing up on the page because it is part of the JavaScript. It's inside a script tag. But if we actually drill deeper into it, it's in there somewhere.
I believe you, Felix.
Do you believe me? I'm sure the audience believes me too. Right? Right, guys.
I don't believe you.
And now with that, the script on the page, I'm going to attempt to invite Mr. Ravioli? No.
Rigoli.
Sorry, my apologies. Didn't mean to sound.
Olivero Rigoli.
Olivero Rigoli. Did I spell it right?
Yes.
There we go. Olivero Rigoli to view this page.
Okay, I'm going to get ready for this.
Great.
Exciting.
Let's switch screens. Don't click on it yet. Don't click on it yet.
Waiting for the email.
Yep. So what the malicious payload does is that it intercepts the access token and sends it off to an attacker-controlled server.
Well, nothing seemed to happen.
Nope, nothing seemed to happen. How odd. Let's switch it back to an attacker-controlled server and see what happened. So in here, the payload has triggered and has taken Mr. Olivero Rigoli, not Kirk, access token. And now the attacker have gained access to this, which means that he or she can actually just copy it, if I can copy this, and reuse it. And
Copy and paste way easier on Windows, just saying.
it is. Wow.
You know now you can even paste and copy from the command prompt. It's like one of the headline features of Windows 10.
Really now, Kirk? Really now?
It's true. It was actually quite exciting.
So in here, you notice the login link for a standard user. I'm currently logged in as my own personal email for the antisocial network. Axolotls are the future.
Not on the antisocial network.
Yep. This is Kirk's access token. I'm about to take the link I have and replace my access token with the one I've taken. Boop. Let's try it. Take two.
Oh, yeah.
Yeah,
you got to log out.
You have to log out. There we go. So I'm now logged in as Mr. Olivero Rigoli, and I can make a new post.
So other things you could do with XSS is put up fake login pages and things like that. But let's look at how I defend against this. So first off, my defense against the subject, like why didn't that work? And so we'll just pop down to my view. When I output the post, I'm using Razor, and by default, if you use that syntax, at symbol and a variable, it'll HTML encode it for you automatically. So it's good, falling into the pit of success. But the way my application works, I actually want people to enter HTML in some places. So let's talk about who we should trust. So the way I build my applications is I trust nothing. And I think it comes from watching the X-Files too much. But basically, hey, it's coming out again, isn't it? How exciting. Everything that's in my database, I don't trust. It got there somehow. My application probably put it there, but maybe not. I don't trust that stuff. And that means that as that data flows out of my database and back into the application, none of these layers should trust it. I want to make it safe for the user to view in their browser or to receive by email. But the way to do that is different depending on whether it's in a browser or an email. So I want to make it safe at the last possible point in my view, and that's where that Razor view doing the HTML encoding protected the subject. But it's a little bit different for this HTML. I actually want people to use the rich text editor and edit HTML, so I want to store HTML in the database. And that means when I store the user's bold tag with hi in it, I want to return that right to the browser so it renders as HTML and bolds the text. So I need to store HTML in the database, and I need to make it safe for the user, but I still want it to be HTML. And this is actually a really hard problem in computer science. And I don't know why it's a hard problem. It's not as hard as regular expressions, but for some reason, we never seem to be able to do it properly. And that's sanitizing HTML. And so I've made a decision, I'm going to sanitize it on the way in. So I had two choices. I could sanitize it on the way out or the way in. I've decided to do it on the way in, so I only have to do it once. But that means that on the way out, I can trust it. In my database, I'm storing HTML, and my application can trust it. So normally I denote this with a different column suffix to say this is trusted, or it's HTML, or it's pre-sanitized, already sanitized. So I'll show you how I do that in my app. I'm using this library called HTML Sanitizer. It's on NuGet. spelt with a Z. It seems reasonably good. It hasn't undergone a thorough security review. We don't use it at 0, so use it at your own peril. But it seems reasonably okay. Nice little sandboxed, self-contained HTML sanitizer. And what it does is it has a list of tags that are safe, attributes that are safe, and it removes all the other stuff. So some CSS properties that execute JavaScript, script tags, on mouse over, all the kind of dangerous stuff gets removed and only the safe stuff goes through. So the way I'm going to do that, so as I said, I do it on the way into my application. So I have a controller called post controller, and there it is. And that creates a post based on input from the user. And at the moment, I was just taking the user's input and putting it straight in the database effectively. And now I'm going to call my sanitize method on the same data and pass it through my stack as sanitized. So now Felix's attack won't work.
Are you sure?
Yeah, I'm sure.
Are you certain?
Yes.
Should I refresh the page and see?
No, you shouldn't.
Oh, goodness.
So the thing we want to talk about is email. So email is a big attack vector for social networks, but our one, it's even worse because we take user content from email and display it on our website.
Indeed, and a user can create a new post via email simply by sending an email to post@antisocial network. So, as you can see, it is not difficult to send an email just by typing in a sendmail command if you have a mail server running somewhere. So I'm going to attempt to send a mail from my mail server.
Wow, this is groundbreaking.
This is, isn't it? I'm about to send an email.
Okay, cool.
From. Who should I send it from?
I don't know, Felix. Yourself?
Kirk. At pageofwords.com to Kirk, because I'm boring like that. And I'm about to try something interesting. So, as Kirk mentioned earlier, he managed to sanitize the input coming in from the web application. But I'm about to test to see if input from an email gets sanitized as well. So I have this mail prepared earlier called defacement mail. It's a nice name, isn't it? And I'll show you what it does. So the subject, it's simply, you smell funny, and it executes it. It's got embedded JavaScript inside it. So
you're going to have to send that to the antisocial network, not me.
To the antisocial network.
I'm not opening my email on stage.
Who knows
what's in there?
I will keep that in mind.
No, post at.
Yeah. I will keep that in mind. Give me a moment. Boop.
Post at antisocial network?
Yeah, post at antisocial network. That's right. Post at social. Looks good.
Awkward pause while Felix sends an email.
Awkward pause.
So the problem with email, as Felix is demonstrating, is that anyone can send any email as anyone, and the reply will go back to anyone. You know, basically, email is all fake. And
Don't trust emails.
Because you used my personal email account for this demo, I am now going to have to open my inbox.
Oh no.
Dick.
You smell funny.
So the reply went to me, and Felix's unsafe content came in via email and changed the subject, the title of the website using cross-site scripting. So as a developer, I hadn't considered sanitizing the email HTML that came in. So let's just look quickly how I do that. So my email comes in through a separate controller. There's a method that handles incoming email, and blah, 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 blah. By the end of it, I get to a sanitize method.
So for the developers out there, it is actually very important if you're doing sanitizing on input to ensure that every possible input points are sanitized, or at least go through a layer of sanitization. For example, build it as a part of your architecture, as part of your pipeline. Ensure that every input gets sanitized before being used or encoded prior to output.
Cool, and now the next one that he sends will be sanitized on the way in. So this kind of boils down to a whole bunch of issues that affect big companies around email and affect users around phishing and things like that. So let's talk about how email works. So there's actually two parts to an email, and it's very similar to physical mail, which is a thing that people used to use back last century. And what they used to do is they used to have an envelope where they'd write the address of the person they were sending it to and their address on the back of the envelope, and inside it they'd stick a letter and post it to someone. And the postman would be able to read the outside of the envelope, but not the inside, unless he's nosy. So this is kind of how email works. We have the actual message. This is what you see in your email client. It's got a from address and a to address. And then you have the envelope of the email, which has a sender. And the user never sees the sender on the email. It's not displayed to them. And it's just used by the mail server to decide, do I trust this email based on who the sender is? The sender doesn't even have to be the same as the from address of the email. And for a lot of email you receive, they'll be different. The last thing that gets tracked with the envelope is the IP address of the user, of the server that sent it. And it can all be spoofed. So like Felix was able to send messages as me to the social network with HTML inside them, you can get messages from major banks, airlines, anything, pretending to be them with urgent security updates. This is just a part of the internet that we understand. So Felix is now going to show an example of phishing.
Phishing, scams, spammers. Well, phishing is an attack when an attacker impersonates or pretends to be someone else and requests your personal credentials. Chances are there are spear phishing attacks on major corporations pretending to be the IT administrator, requesting their users to reset their password and redirecting them to an attacker-controlled website, where then the passwords and credentials are promptly stolen and used for nefarious purposes. Yep. So for this, I have a mail server running and on my local machine, so I would now pretend to be an attacker. I am an attacker, silly me. I would pretend to be, let's say, the accounts manager from the antisocial network. Say, accounts at dev.antisocial network. That sounds legit enough, doesn't it? Yeah.
Cool. So what he's doing here is setting up the envelope, right? So the mail from is the envelope sender. The receipt to is who the envelope gets delivered to.
Which gets delivered to Olivero Rigoli. And now I'm typing the actual message of the email.
So the body of the email just goes in as plain text, and the mail server doesn't really look at that when it's routing email. It looks at the envelope, just like the postman doesn't look at the inside of your envelope, your letter inside the envelope. It's not going to work because you didn't put a colon after from. It's going to really suck.
Thanks. Type on the stage. Change your password immediately.
So this is my vision of what people in Nigeria do. They telnet to servers and they type email in. But actually there's a whole bunch of software that does this. There's the social engineering toolkit, which is like a bad guys version. You load a bunch of users you want to socially engineer and send out spam. There's a good guy version, which is
Simple Phishing Toolkit,
yes.
which is actually used for training, internal training and auditing purposes.
And Felix actually sent that to Oliver rather than Olivero. So, Gmail. I'll send him a link to this talk afterwards. I'm sure my grandmother to translate it into Italian so he understands what happened.
Yep.
So you can see the email is unauthenticated. You can just connect to any mail server. You can enter any text you want and the message gets delivered. How do we defend against this? Well, it's actually a real pain in the ass. There's three protocols. SPF and DKIM have been around for ages. I want to talk about DMARC because that's what social networks are using now to protect their users and their brands. And that's what companies like ours can use as well.
Yeah, so what is SPF? SPF stands for Sender Policy Framework. It is a validation framework for detecting email spoofing and spamming. So what exactly do we use SPF, Kirk?
Yeah, so basically SPF just says these IP addresses can send mail from my domain. And so there's a text record that you put into your DNS. So I've put one in anti-social network, and I've just said the only IP addresses that can send mail from my domain are mailgun.org.
So does that mean anyone from mailgun.org can send it from your domain?
Potentially. You want to restrict that IP range to something small. And basically you're saying the recipient says, okay, I've received something from your IP address on the envelope. I trust that the domain name you've said is right.
Great. And DKIM stands for Domain Key Identified Mail. Very much like SPF, how SPF protects the envelope. DKIM ensures the message integrity of the actual body of the message. So in a sense, you're actually adding a public key record to your domain's DNS, and you sign all your outgoing email with a private key. So, for example, in this case, Kirk, would you like to run through this?
Yeah, so here's the example of the signature on one of my emails that came out from the anti-social network. There's two huge blobs of data in an email header, which is a signature of my email, and the recipient can look up my domain name and the name of the record and get the public key, and then rerun the signature algorithm to check that it matches what my signature had with the private key.
And what if the keys don't match?
If the keys don't match, then they can make a decision like, so the message, like the letter of the message, isn't signed by Kirk, but it says it's from Kirk, so maybe I should throw it away, maybe I should warn the user. And there's just what I put into my DNS. So there's a big long public key, some mathematics happens, and the mail server that receives it goes, I trust that message. So SPF and DKIM are protecting, SPF's protecting the envelope, DKIM's protecting the message. And the problem with these two protocols is that even though they've been around for ages and some people use them, mail servers typically just take it under advisement and don't actually block email. So if I'm face-based, and I'm sending out emails to customers, and someone like Felix is pretending to be me and asking for account resets from my users, the recipient mail server will go, well, it fails SPF and it fails DKIM, but you know, lots of things do, so I'm going to let it through anyway. And so Yahoo and PayPal, so PayPal shift money around, and Yahoo have a lot of gullible customers. They got together and said, how do we stop our gullible customers from shifting money overseas without realizing it? And they came up with a protocol called DMARC. So just to show where it fits in, so SMTP is unauthenticated. We've got these two old protocols, and DMARC's sort of about 4 years old, and it adds a layer on top of visibility and policy on top of SPF and DKIM. So the policy declares what to do with unauthenticated email. So for my antisocial network, I want to say to recipient mail servers out there, if the mail is not from me, please throw it away. And the visibility lets you know what's happening out there on the internet. Those mail servers that throw the mail away or detect something dodgy send information back to me saying, I've detected something dodgy here, have a look at it. So here's an example of a DMARC record. It's a reasonably simple one. The policy is only report on my one, because otherwise Felix's demo wouldn't work. So just report failures, and then here's where you report them to, which is 2 email addresses. And what Gmail and Yahoo and AOL and all those recipient mail servers do is bundle up all the failures for the day and email them through to the report URLs. So just to demo how that works, you smell funny, go away Felix. I'm just using a tool called Agari, so you have to pay for this, but there's other ones, just this is the one I'm familiar with. So this lets you look at your DMARC records, so that's pretty straightforward. It gives you a nice kind of what does this all mean kind of thing. And then what it also lets you do is dig into threats that have come in over email. So Antisocial Network hasn't really picked up yet, so I'm using another organization called Sashimi Bank. They are a bit bigger and receive more email. Here is a threat map of the email they've received across the world. If I just turn bits on and off. So here's all the email that I've sent, the Sashimi Bank has sent from places that they put put in the SPF and they know they're sending from. Here's the failures that have come in via phishing from around the world, and they've been blocked by the email ISPs. And here's the ones that they haven't blocked but are kind of dodgy. And then you can drill into them. So if I scroll down here, here's the top 5 threats that have come in via email. So, someone sent out an email saying they're security at the bank and that you need to change your password. And you can drill in and, Gmail, AOL, Yahoo have sent in metadata about the messages that they're blocking. You can look at the message, look at the IP address. So, this one's got an SBRS score saying that that's a dodgy IP, and, it's a probably likely spammer. It also shows you the URLs that they're using. And so here you can see there's an actual phishing URL as part of the email. So this is kind of like stuff that you'd never see before with email. You can see email going out of your mail server, but most companies send mail from like tens of different systems. There's the corporate mail server, there's the the thing that lets people sign up for jobs, there's all these different things. But what this does is it looks at what people are receiving and gives you information about that. And that's how the DMARC protocol works, sends back those reports. And then you can send this URL off to a takedown vendor to say, take down this fake site that's pretending to be us. And they'll do that for a small fee of $5,000.
Small.
So that DMARC lets you do is to keep track of what threats are coming in. So like I said, different URLs that are dodgy. At the moment, there's only one listed in there. And it also lets you figure out what domain names you use, because you put the DMARC record in and then you start getting information about all your domain names coming in, and you find out, oh, actually, I'm using 10 different domain names for my email. SPF is only working on 95% of the one that's our corporate email. That's really weird. I can drill in to see why is SPF not working on that domain and look at what Google and Yahoo and AOL and other mail senders have sent in as the reasons, and search for samples of those failures. And so the samples, I think I already showed the samples, didn't I? So it's really good also for figuring out, what do you send email on. So I'm not trying to do a demo of the tool. I'm just saying this is the data that DMARC provides you. And so social network can use this information to protect its users.
So let's attack again. Where are we going with this? Kirk, why don't Mr. Oliveira Ravioli, I think it's time for him to check his email.
Oh, cool. Did something arrive while I was talking?
Yeah. How to hack anyone's anti-social network.
Oh, cool. I've always wanted to know how to hack other people. Okay, so hack anyone's social network with the following snippet. First, click on the link in an email sent to you. Right-click on the page and click on Inspect Element, then click Console. Okay. Inspect Element. Oh, this is going to be cool. I can hack people. Okay. Copy the attached snippet into the console. That's weird. I wonder what that does. It must be magic. And I have to change victim's email address to someone I want to attack. Felix. He's a pain. Cool. And then what do? Press enter. Okay, that was easy. Cool. I've attacked Felix.
Now we just wait for a nice confirmation email saying, hey, this is Felix's access token. But in reality, this is actually a very prominent attack on social networks, strangely enough.
Who ever thought that the developer console in browsers was common among mainstream users?
I know. Well, most mainstream users doesn't know about the browser console, and worst of all, they don't actually know what that obfuscated string of garbage is. So in reality, what he's done is that he actually just ran the JavaScript that sent his access token to the malicious attacker again. This attack has been used against Facebook and MySpace to actually, for users to voluntarily giving away their access credentials. So I think, Kirk, how would we actually educate users on this?
Yeah, so the thing is here, like my website's totally secure now. I fixed all the bugs, and but users are running JavaScript in the developer console that's compromising their cookies and attacking them, sending their credentials somewhere. How do I protect against that? Well, it's kind of a browser feature to be able to run JavaScript in the developer console. So what Firefox have done now, and it doesn't seem to show up all the time, is they give you a warning when you try and paste something into the browser console and say, are you sure you really want to do this? And this is why they're giving that warning, so that regular users hopefully don't get owned.
Or get phished. I mean, when you think about it, if they actually try to attack another user, they kind of deserve it. Well, maybe not.
Yeah, and there's lots of other social engineering attacks that happen on social networks. And so what they need to be ready for, I guess, is these things making their way around the network and quickly take them down by filtering the content or blocking it some way. And that was the case in MySpace's example with the Sammy worm. It actually took down MySpace because everyone was friend requesting everyone else, and this worm was following, and they actually had to take MySpace offline while they cleaned it up.
Yeah.
Man, imagine that, MySpace offline, the world would stop moving.
Imagine.
This kind of leads into scale and propagation.
So, unlike traditional web apps, you have separate users and they're all segregated from each other. In a social network environment, people are connected. Well, nobody's really alone. Everyone has friends, maybe except for Kirk, but that's a different story. He's got Andy. Hi, Andy.
Andy has no friends. So I actually built a social network on the premise of not having friends. So,
well, let's say, hypothetically speaking, Kirk have friends. Kirk have 5 friends. Let's go with 5. That's a good number.
Yeah.
And on the unlikely situation where Kirk's account was compromised and the attacker decided to send off malicious like malware from Kirk's account, his friends are more likely to trust Kirk than actually to trust the Prince of Nigeria, with all due respect to the Prince of Nigeria if you're in the crowd. And if it is a self-propagating worm, the friends will send it on to 5 of their friends. And it just goes up exponentially. 5, 25, 125, some scary big number, and then at the end, you have a catastrophe. Catastrophe, even. I'm sorry. I'm sorry. It has to be done. Yep. And that is what's so dangerous about it. In a sense, when you think about social network, the interconnected nature of it makes it very difficult to just take down a certain bug, like a certain piece of code, because chances are it's going to spread inside the network.
So the thing I guess that we've seen today is that a social network's not that much different from a regular app, except that it has scale, and that your brand is, I guess, being targeted a lot more. There's some ways you can protect against it. We've seen some attacks XSS. The one where the user ran their own JavaScript is called self-XSS. We've got a bunch of other talks on our website and on Ignite's website with other types of web attacks. And you need to protect against all of them. The things we've met today, we just looked at encoding, sanitization, some user education, and preparing, I guess, for scale attacks. But you know, for every attack that costs $5, you're going to need to put $5,000 worth of effort into defending. It's just an unfortunate reality of the scale problem that we see. So we've actually got 10 minutes left, Felix. Shall we just do another demo?
Let's do another demo, eh?
Okay.
Yep. Cool. So there's another attack that is actually, they used to be very prevalent on social networks, known as crowd-side request forgery. Has anyone seen that in the wild before, or heard of it in the wild? Oh, nice. Great. So, is my screen being shared? Yes, it is. So what we have here is a page hosted on a malicious environment. It contains a form that automatically gets posted when the page loads. But if we look at where the form is being posted to, it is being posted to a URL in the anti-social network. So whenever someone visits the page, the browser will make an involuntary request to the antisocial network, and they will post something in the post ID. Let's have a look to see what that post actually is. Let's copy this. The post is, "I'm so lonely. Will you be my friend?" Or it will post a reply to it, and with the value, "I'll be your friend." So I've hosted it somewhere on the internet. Let's get back to Kirk and...
So now Felix is going to trick me to go on the internet, which is not hard because at work I spend most of my day there. What's the website I need to go to? Are you going to fish me?
Yes, I am. I'm not going to fish you. I'm a nice person with happy feelings. I'm going to send you cat pictures.
Oh, thanks.
Catpictures.exe.
So I'm going to open up Live Mail and read my inbox. And sitting in there is going to be an email inviting me to look at cat pictures. This also could be somewhere else on the social network. A link off to an external site saying, look at pictures of Katy Perry twerking or whatever Katy Perry does. Did you email that?
I'm sure I did. Today is not a good demo day, is it? Did I send it to Oliver again?
Yeah, I'm logged in as Oliver.
I'm sorry, Oliver.
Oh, I'll just find the last one you sent. You sent one to me before? Cool. No, that was me sending one to you.
Nope.
Okay, just tell me the URL.
I will just tell you the URL. Just 54.69. Today is not a good demo day. 182.3/cat_pictures.
Oh, cute.
.html. Feel free to visit it yourself as well, if you're feeling adventurous. Well, where did the cat pictures go?
That was pretty lame cat pictures. So that could have obviously been any web page. And while I'm visiting it, something's happening in the background that's without my knowledge.
And for that, if we go back to my screen for a moment.
Yeah, I can look. So let's look at what's actually happening. I'm posting messages to the social network saying, I want to be Felix's friend.
Yeah.
Or not.
Or not.
So CSRF is a nice attack, and it's, I think, actually the SAMI worm with CSRF plus XSS.
Is it? Oh, sorry.
And there's some good defenses for it in ASP.NET. So if I want to stop another website from being able to trick a user into posting data to my website, in ASP.NET I can turn on the anti-forgery token functionality. And what you do is go to your controller. This is the most basic way, at least. And I've got this action method that takes in reply HTML, and this is the one that he's posting to. And I just need to put the validate anti-forgery token attribute on that method. And what this does is it adds an extra, in your website, you have to add an extra hidden field to every page, to every form. So where is my reply form? Yep. And so you have to add an extra hidden field here, and the attacker won't know that hidden field from me when I'm logged in. So his form that he hosts on the Cat Pictures website can't post to it.
Exactly, and also it is actually quite dangerous, a cross-site request forgery attack, that is. For example, imagine this all too familiar scenario. If you want to change your password, you have to type in your existing password in order to change it. Most well-designed secure website does that. But there are a few where you can actually change your email address without providing your current credential. And as we all know, you can actually send a password reset link to your email address. So there are quite a few attacks out there that utilizes CSRF to change the email address to an attacker-controlled email and then proceed to reset to gain access to the account via, I forgot my password. Please send a password reset link to my new email address. And there we go, account compromised. Quite terrifying, really, isn't it?
So we've got a more in-depth demo of CSRF. Takes a little bit to get your head around because the attacker's tricking the real user to do something. They're visiting a malicious website, but they're doing something themselves, and so the normal authorization checks in your web app don't protect it. I've got a website with previous talks you can go and look at. There's also the OWASP website, which is really good. Something that I haven't shown you yet is this cool project called Report URI. So there's a protocol called Content Security Policy, which you can use to stop cross-site scripting, pretty much. And what you do is, if you use the Report URI site, it helps you with documentation of how to do this. You specify where your JavaScript's going to come from, where your fonts are going to come from, where your style sheets are going to come from, and you specify whether you want to block failures or whether you want to report them. And I've set mine just to report failures. So I've got a URL that I put in to my content security policy that says report failures to this address. And it gives you a policy to add as an HTTP header. So it's pretty easy to do that in MVC. You just add an outgoing filter. So I've got one called CSP filter attribute, which just adds this HTTP header to every response. And now when a user visits my website, if there's any JavaScript errors or images loaded from domains that the website author doesn't expect, it'll send reports into this tool. And the reports come in with details of the attack that was against the user. So Felix tried to get me to access his web server. Something tried to connect to localhost. That was the IP address, I think, that you were using just before with your cat pictures.
Indeed.
And so as a website owner, this is another feedback mechanism where you can go, stuff's happening out in the wild. My users are getting attacked, but I can't see what's happening because it's in their browser. This is content security policy lets you grab those messages and bring them back into your environment to analyze. And Scott that made this report-uri.io website, it's currently free, but you can roll your own as well. Does a little bit of analysis over it as well, so shows trends. My website hasn't been around for long, so it doesn't have much of a trend. The top 10 attacks that have been happening against your site, and the pages that they've been happening on, and locations of where those attacks have been coming from. So that's a really cool tool that we've linked to in the resources there. There's the HTML sanitizing project. Use at your own risk, but it looks reasonably good. If you're interested in further training, Troy Hunt is an ASP.NET, he's a developer security MVP based in Australia. So he has some really good training videos on Pluralsight, lots of great information on his blog. Recommend you go and check him out. He's got a great Australian accent and he pranks Microsoft scamming phone calls with dingo noises in the background, so it's all very funny. There's also local web security events, Wellington, Auckland and Christchurch, and a conference that's on in February. I'd encourage you to Google that and come along. And Felix and I really enjoy listening to the Risky Biz podcast, which rounds up the week's security news in a nice succinct format while you're commuting.
It really is. It's thoroughly enjoyable. I'd strongly recommend it.
Cool. Before we finish off, I'd like to thank you guys for coming and thank Andy for all of his input into this talk.
Thanks, Andy.
And for his sudden and quite short notice inability to come due to pressing business concerns. If you would like to in turn thank Andy for not coming, we have a permanent marker where you can write your thanks to him and we'll deliver this to his office so that he can see what you think of him.
And yes, and he is the CEO of multiple companies, so we'll actually display it in a rather prominent location.
Yes.
Let's do that.
Cool. So we've been Felix and Kirk. Check out our antisocial network. It'll be launching soon. If you're an investor, please contact us. I'm at KirkJ on Twitter, and Felix is Comrade Para.
On Twitter? I think I misspelled it, yeah.
That's not right?
I think I dropped an E. Oh, well, but that typo happens.
Okay. Yeah, thanks very much for coming.